Hey guys, before we get into the show, just want to let you know we're looking for some people to help out with Seller Sessions Live on June 1st. If you have some background in events management and are UK based, drop me an email to danny@sellersessions.com. Hey guys, welcome back to Seller Sessions. Again, I bring back Jared Ha. How you doing?
I'm doing well, thanks, Danny. Thanks for having me on again. I appreciate it.
Not a problem. Okay, so today we're going to niche down and we're going to carry on with the manufacturing process, but today we're going to be talking about prototypes and what they are. So without further ado, I'll let you kick off.
Yeah, so prototypes, they're basically just a way to verify that the design that you have came up with works. So when you're developing a process, you have an idea and you're developing it towards a certain market. However, what you see on CAD might not really work in reality. So a prototype is just a quick way just to make sure that what you have on CAD is verified. And so for some certain prototypes, you can't really get it the first time, and you have to make sometimes some trial runs. So the point of each prototype is just you verify the previous development step works.
Yeah, that makes sense. And I take it there's lots of variables there, isn't there? Because you're going to do it in process of each step of the development. So it's going to have a kind of aesthetical version, and then there's going to be the functionality as well. And they all kind of integrate in terms of testing and making sure each of those stages work.
You got it. Yep. There's really two types of main prototypes, and it's to test the functional part, and it's to test the aesthetics part.
Cool. That makes sense. So let's talk about verification of design and engineering, etc.
Mm-hmm. So when you have a product or a design, you're going to have to set certain quality standards for that specific prototype. So, for example, if you're designing let's say a new pen or something like that, you're going to have to make sure that each part fits within the units. So if you're going to be designing the cap, it's going to have to be sitting on the top of the ink, and then on the top of it as well. So for CAD, it might be all great. It might look great. However, there's some sort of variables of when you actually make it. There's some shrinkage and things like that that could be verified during the production or during the sampling and prototyping process. So each design change that you make towards your product, it's going to have to be verified through a prototype. And how you verify it is just having some sort of quality standard or quality parameters that the client and the manufacturing company will set up together.
Okay, makes sense. So talk to me about quality reports, production documents and stuff like that.
Yeah, so for production documents, that's most commonly referred to as the work instructions, and that's basically the procedure that the online assembly workers or the labor on the machines will follow. So for each part that has to be processed, there's going to be work instructions for that. That's mostly going to be developed by the manufacturing company. So let's say if you're assembling a pen or something like that, there's going to be work instructions of how that pen is supposed to be assembled on the line. For quality requirements, it's going to be checking that the pen was assembled correctly. And there's going to be mostly two different types of specifications, functional and aesthetics. So for functional, you're going to want to, if it's a pen again, you're going to want to make sure that it writes well, that it doesn't fall apart, the cap is able to screw in and things like that. For the aesthetics, it's mostly going to be, is it transparent? What kind of, is it smoky translucent or is it fully transparent? And then what Pantone colors? And for the quality specifications, that's going to be it's going to be developed by both the contract manufacturer and the client, but you guys both have to agree on it. And it has to be as objective as possible. So you don't want anything that says minimal gap or anything that has to have some sort of specifications with actual numbers.
Makes sense. And in terms of, just a side here is that in terms of marketing, like crowdfunding, etc., the great thing about prototypes is that you're able to, maybe what we'll go into later about proof of concept, but you're able to get that process started in line with your manufacturing as long as you've got a basis of a proof of concept. Is that correct?
Exactly. So if you want to run a Kickstarter or Indiegogo or any sort of crowdfunding campaign, all you need is a sample, and then you could go on. You don't have to have thousands of products in inventory. All you need is just one sample that looks good that you could launch. And then you could go from there. And then you could see how the market reacts. You could see if they like it or if they don't like it. You could hear some of the feedback if you have to make some necessary tweaks to it. And then you could go back to the drawing board and implement those changes.
Makes sense. So talk me through different types of prototypes out there.
Yeah, so the first type of prototype, that's going to be called proof of concept. And the goal of this is just to verify that the concept works. So you're not going to be using mass-produced materials or anything like that. It's just to verify that the concept works. And if the proof of concept fails, then you have to develop a brand new concept. So that's always going to be step one, just to make sure that it works. The second step is going to be to develop a functional prototype. And this is going to be more for mechanical and electrical components. And the goal is to have a product that works exactly as a product is imagined to be working. So similar to the proof of concept, it doesn't have to look great. It could look pretty crappy, but as long as it works, that's fine. So for the functional prototype, for an example, if you have an engineering change, you're going to have to make a prototype of the unit that changed or the part that changed to make sure that it could fit with the other pieces so that the unit could work properly. The next one is that after it functionally works, you're going to want it to look good as well. So that's the purpose of the aesthetics prototype. So the main things that you look at is just to make sure it's as ergonomic as possible. So if you hold it, you want to make sure that it's a good feel. And then you also want to answer some questions about the color, the shape, and the feel. So the color, sometimes if you have a rendering of it, it looks great, but when you make a sample of it, it doesn't look that good. There's some issues with matching colors and things like that. Then also the shape, does it have the desired shape for the market? And for the feel, is it comfortable when you hold it or are using it? And then the golden sample is more looked at as kind of like the final sample that brings in the aesthetics and the functional parts. So when you have this one, it's a green light for production as well. So if you have a golden sample, that's when the contract manufacturer or factory, they could start to make the quality requirements and the production reports. They could probably also provide you with some production scheduling as well. And this is a sample that you could take to investors, or you could also launch a crowdfunding campaign as well. And then once all of this is done, you have the demands, you know exactly what your order is going to be. You could, that's when you launch, you could do some tooling, you could start the tooling process. And then the next step of these, it's not really a prototype, but I consider it still a type of prototype, is a pilot run.
Yeah. Break down what a pilot run is.
So a pilot run is a small percentage of the overall PO. So for an example, let's say if the PO is 1,000 units, then the pilot run could be 10%, meaning that you'll launch or you'll build 100 units first. And that's just to make sure that production runs smoothly. So you want to get out all the kinks for some quality defects, and also to make sure that you don't have capacity issues as well.
Yeah, so at that stage, for instance, that's based on scale. If you have got quality defects and you've got like a higher percentage, this is where you can engineer them out at this stage. So on the mass run, that's going to reduce the overall percentage of defects, yeah?
Exactly, yeah, because you'd rather have, like the first 10% bad rather than the complete order be bad. So that's usually why you start with a small percent. And this is just for the first run. For the second, third runs and, onto the future, you don't have to have a pilot run, which is why I consider it a prototype, just because it's just to ensure that, everything's okay with the tools and to ensure that production can run smoothly.
Cool. Makes sense. So talk to me about the development of production reports, work instructions. I know you kind of mentioned them earlier, but do you want to go into what they are?
Yeah, so once you have the golden sample, that's when you could really start to make the work instructions and the quality documents. so for the work instruction, it's kind of like we talked about before. It's you could take the golden sample as a reference, and then you could kind of deassemble it, and then what's the best way to assemble that golden sample, and then you could make some reports off that. So each part that is touched is going to have a work instruction on it. So let's say if you have a relatively complicated project, you could have hundreds of work instructions. For quality documents, you also take that golden sample and you go into detail about the functional and aesthetics parts. So for functional, let's say if there's some buttons on it, you could have push tests. So if you expect it to be pushed 10,000 times per year, or if you expect lifetime to be pushed 100,000 times, then you could certain factories, we have machines that will just be constantly pushing that button to make sure that it doesn't become weak and that it stays strong and it does not fall off. So during the quality specifications, that's when you really try to make the product's parameters as objective as possible. So if you could use go, no-go gauges, which basically one end is no-go, the other end is go, it's just to make sure that the part is within the parameters. There's salt spray tests that you could do. There's pull tests. There's drop tests, things like that. And then for the aesthetic side, you have to define the Pantone colors. You have to define scratches. Or are there allowed can you have scratches? If you're allowed scratches, then which surfaces can have scratches? Usually there's A, which is the most visible, B, semi-visible, and C, which is maybe on the inside of the housing and you don't really see it that much. So all of those things are going to be defined in the quality specifications.
Makes sense. So talk to me about lead times of your production.
For samples,
Yes.
usually for plastic, it's anywhere from 1 to 2 weeks. And this doesn't really depend on the complexity because you can just do 3D printed parts. For metals, you're going to bump it up from about 2 weeks to about a month, maybe 3 to 4 weeks. And the reason that you could have an extended lead time is because sometimes you have to open up some tooling.
Yeah.
Just sample tooling is going to be cheaper than mass production, or depending on the production line, some tools for samples could also be used for mass production as well.
Yeah.
And then if you're going to be doing electronic components, it depends on the complexity, of course, but usually you could look at it for about 1 month, 3 to 4 weeks to get an electronic sample.
Sounds good. Talk to me CNC, 3D, etc.
Yeah, so usually if you're going to be doing plastic, the most efficient way is going to be doing 3D printing. However, there are some tolerances. So if you need the samples to be very tight tolerances, then you have to do CNC. The tolerances for CNC usually are around 0.05 mm, so it's very precise.
Yeah.
But it's also more expensive, and you also have to get more tooling. So if you're just looking for just to see if it for a basic function, if it works, 3D printing should be fine. If you want aesthetics, 3D printing should be fine. But if you need something to be very precise for a certain component, then you might have to do CNC.
Yeah. So, which brings us on to a die cast.
Die cast, unfortunately, you actually can't do samples of die cast.
Right.
And the reason that is that you actually have to open up a tool or a mold to do die cast, similar to plastic injection molding, which is why for plastic injection molding, you do 3D printing. So for die casting, you could do 3D printed metals, but it's pretty expensive.
Yeah.
So that's why you will do, for die cast, you usually will be choosing CNC. It might take a little longer. It might be a little bit more expensive because of the cuts. However, it's the most cost effective, and for lead time, it's also the quickest.
Cool. Is there anything you would like to add before we go?
Not really, actually. I think that really drills down the prototype portion.
Sounds good. So what's the best way that people can reach you? Obviously, you're in this business helping other Amazon sellers and people that sell on other channels. So what's the best way to reach you, etc.?
You can reach us at ePower Corp. That is EPOWERCORP.com. And you could always follow us on LinkedIn, or you could shoot us over an email at hello@epowercorp.com, and we'd be happy to answer any questions for you.
Sounds good. Guys, thank you for joining us. Judd, thank you for joining us. If this is your first time, don't forget to hit the subscribe button, and I'll see you again in the next few days. Take care.